Good morning to all of you. Last class we have seen the image formation in the case of concave mirror. I think all of you can recollect. I'm just revising the different cases and the nature of image formed. Case 1, when the object is at infinity, the image is formed at the focus, real, inverted and very diminished image. Case 2, object is little more closer, that is beyond C. The image is between F and C, real, inverted and diminished. Case 3, object is again closer to the mirror, that is now it is at C. When the object is at C, the image is also formed at C, real, inverted and the size of the image is same as that of the object. Of same size image is formed at C. It's a very important point. Next case, object is coming again closer to the mirror. Object is between F and C. Then the image is formed beyond C, real, inverted and enlarged image, magnified image. Again, the object is coming closer to the mirror. Now the object is at F, focus. Image is formed at infinity, real, inverted and highly magnified image. So this is the condition to get highly magnified image. Again, the object is coming closer to the mirror. Now the object is between F and P, focus and pole. In this case, the image is formed behind the mirror. It's a virtual, erect, enlarged image. So only in this case, concave mirror can form virtual image. In all other cases, it is a real image. So you can see real images are formed in front of the mirror and virtual images are formed behind the mirror. And in the last class, we have seen real images can be taken on a screen, whereas virtual images cannot be taken on a screen. But both can be photographed. I think all of you completed these diagrams. There are 6 diagrams. Image formation in the case of concave mirror, you should complete all these 6 diagrams in the copy. Okay, so regarding concave mirror, we have completed all the points, image formation. Now today we are going to see convex mirror and the image formation. After that we'll see magnification. What is the meaning of magnification? After that we see the sign convention according to Cartesian coordinate system. Okay, now we are going to see the image formation in the case of convex mirror. And we'll see the corresponding diagrams too. Convex mirror image formation. Convex mirror forms only one type of image. Only one type of image for all the positions of the object. Wherever you keep the object, only one type of image it can form, that is virtual, erect and diminished. So convex mirror always produces virtual image are erect image and it is diminished. Okay. So convex mirror always produces virtual, erect and diminished for all the positions of the objects. And in this case, we have to see only two types of image form. That means two cases are there. One is object at infinity, and second, object at any finite distance. Any distance, say 10 centimeter, 30 centimeter, 50 centimeter. That we call it as finite distance. So here we discuss the case one, that is object at infinity. Object at infinity. Object at infinity. In far, very, very far. Object at infinity, very, very far. For example, sun is an object, can be taken as at infinite distance. When the object is at infinity, where will be the image? It's a repetition of the definition of principal focus. So we'll see here is a convex mirror. Principal axis P, C, and F. P is the pole of the mirror, C the center of curvature, and F is principal focus. I think you know the distance. PC is radius of curvature, R, and PF is the focal length, and the relation F equal to R by 2. I think you remember this relation, it's very important one. Focal length is half of the radius of curvature and remains same in all medium. We have seen this point earlier. So, in the case of convex mirror, first case, object is at infinity, convex mirror. So, object at infinity, rays are parallel to principal axis and parallel to themselves. Yes. Object at infinity. You can put some dots in front of this line to so that you can recognize that the light rays are coming from infinite distance. After reflection, these light rays appears to come from a point. So it comes in this way, and it appears to come from this point F. And from here also, after reflection, this light ray will be going in this way, appear to come from the point F. This is the definition of F. So the image is formed at F. This is the image position. So somebody is standing here, and for you, for the observer, the light rays appears to come from the point F. So its virtual image, very, very diminished image is formed at focus. So when the object is at infinity, this is the way the image formation is taking place. So we'll write here, the image formed is virtual image. You can see that is a virtual image. It's an erect image and very diminished image. Very diminished image. And where is where is the location? Location is, it is formed at F. So always virtual image, erect image. It's a diminished. In this case, it is very diminished image, and it is formed at F. So convex mirror, image formation for all the positions of the object. Convex mirror forms virtual, erect, and diminished. So you have to remember, hamesha virtual, erect, and diminished image. Two cases we discuss. First case, one object at infinite distance, very, very, very far. Light rays parallel to the principal axis and parallel to themselves. After reflection, they appear to come from this point O. So at this point O, we get the virtual image. Virtual image, it's a virtual image, erect image, and very diminished image, and it is formed at the focus. Now, case 2, when the object is at any finite distance, that means it's a measurable distance, say 30 centimeter, 100 centimeter, etc. Then where will be the location? That is the second diagram. So we are making the second diagram here. So case 2 we write object at any finite distance, finite distance, that is you can see that 10 centimeter or 30 centimeter or 50 centimeter, etc. Any, etc. finite distance that can be measured from the mirror. And see the image formation here. So I am drawing these two things together. So one diagram is already there. So other diagram I am marking here. So it is easy to compare. So this is your convex mirror, pole, focus, and C. Now your object is here in front of the mirror. We say that it is in front of the mirror. AB is your object in front of the mirror. First ray parallel to the principal axis. This is a ray parallel to the principal axis. After reflection, appear to come from the focus. So this ray will be going in this way, coming in this way it traces, and if you extend, you can see that it appears to come from here. This is the first ray. Second ray of light reaches the pole. This is the second ray, two arrow marks. Second ray of light reaches the pole after reflection, coming back to the same medium, obeying the laws of reflection. Yeah. So if somebody is here on left side, if you are standing here, this is ray number 1, this is ray number 2. These two rays are not at all meeting anywhere. First ray is going in this way, second ray is going, so they are not meeting anywhere on this side. So extend the second ray also backwards. The second ray is also extended backwards. So for you, somebody standing here on left side, rays 1 and 2 after reflection appear to come from point this. This point is A dash. So we get here A dash B dash is the image forms. A dash B dash is the image form. It's again virtual image, erect. But it is not very diminished as in the case of first case. It is diminished image. Diminished, but it is not very diminished. And where is the location? It is found between F and P. And image location is between F and P. So all should recognize these points. Two diagrams are there together, so you can easily recognize. So image formation in the case of convex mirror, when the object is in front of the mirror, say at any finite distance, say 10 centimeter, 30 centimeter, 50 centimeter, etc. So this is about question. So how will you explain this? The concave mirror, principal axis, mark P, F and C. Object is kept in front, any distance you can mark. And first ray parallel to principal axis after reflection appear to come from the focus. Second ray reaching at the pole, obeying the laws of reflection, reflect the same medium. Ray number 1 and 2 after reflection, they do not meet anywhere here on left side, but appear to come ke liye you have to just make dotted lines backward, appear to come from a point here A dash. So A dash, B dash, you will get the virtual image. It's erect image and diminished, and it is found between F and P. Only two diagrams are there in the case of convex mirror. Only two diagrams are there. So one more point I am going to add in this case. Suppose you are moving the object from infinite distance towards the mirror. So initially it was here. Object at infinity is here. This is the object at infinite distance we mark. Object at infinite distance. Very, very far. So the object is coming closer. Object is at infinity, image is here. When the object is coming closer, then image will be moving towards the pole from the focus. See the way it travels. Object is coming in this way, so the image will move from the focus towards the pole of the mirror. So when the object is coming towards the mirror from infinite distance, what kind of movement you can see in the case of the image? The image will move from the focus towards the pole of the mirror. From the focus, it will move towards the pole. So that is the case 2 diagram you can see here. It is moving from focus toward the pole. That depending upon the position, it moves here. So convex mirror always produces virtual erect diminished image irrespective of all positions. You should complete these two diagrams in the copy. I think this is clear to all of you. So next term, so image formation. In the case of concave mirror, there are 6 diagrams, and convex mirror, there are 2 diagrams. Total 8 diagrams should be there in your copy. Okay. Then we proceed for next term. What is the meaning of linear magnification? Linear magnification produced by a mirror. Linear magnification. Next term is called linear magnification. Linear magnification. Linear magnification means we usually measure the height. Okay, thickness is not measured. Height. The object is 5 centimeter. Then what will be the size of the image? It can be 3 centimeter. It can be 6 centimeter. So sometime it will be smaller in size, diminished. Sometimes it's enlarged or magnified. So this idea is obtained by the term linear magnification. It is represented by small letter m. So, how will you define linear magnification? Linear magnification is defined as the ratio of the height of the image. We usually mark A dash B dash, height of the divided by the height of the object AB. A dash B dash, size of the image, height of the image upon height of the object. So, if height AB, suppose this is AB you are keeping, suppose it is measured as H1 and A dash B dash. A dash B dash can be of 2 types of image. It will be inverted image or it can be virtual image. So you have to recognize this kind of arrangement. A dash B dash. Okay. 2 types of image can be, it is a real image and this will be virtual image. Suppose we are marking H2. The height of the image we mark it as H2. Then we see that A dash B dash can be written as H2 divided by H1. This is the first equation that you have to learn. Linear magnification of a mirror, spherical mirror, is defined as the ratio of the height of the image to the height of the object. A dash B dash upon AB, or if you mark the height as H2 for image and H1 for object, then we'll write it as H2 by H1. So you have to learn this equation. This is also related to object distance and image distance. So distance of the object. So distance of object from the mirror we marked as by letter U, object distance, and distance of image from the mirror we marked as letter V. These are the small letters. U represent the object distance and V represent the image distance. So we can also define magnification in terms of object distance and image distance. So that is in this way, but M is can also be related. So this equation you have to learn, it is minus V upon U, equation number 2. No derivation for this, so you have to learn this equation. It's a very important equation for numerical. So 2 equations are in front of you. So you have to learn this equation number 1 and 2. So linear magnification means a term used to see whether the image formed is enlarged image or diminished image. Magnification doesn't mean that always the image should be what? The magnified one. Here M stands for M can be less than 1 means image can be diminished. M can be greater than 1, then it will be magnified image. It's a term generally to recognize the size. It can be enlarged or it can be diminished. So that M will, the value of M will give you the idea about that, whether it is a diminished image or virtual, diminished image or enlarged image. I think this point is clear to all of you. 2 equations are with you. M equal to A dash B dash upon AB or H2 by H1 you can write, or M is equal to minus V by U. So together you can combine equation 1 and 2. So after combining we can write the equation as point number 3 as magnification is equal to A dash B dash upon AB, that is equal to minus V by U. This equation is valid for both mirrors. Okay, you can use it for concave and convex and for real and virtual image. For all the cases, same equation is there. So you have to remember this. This equation is same for concave mirror, convex mirror, as well as for real and virtual image. So this is a minus sign is here. You have to remember this point, and very important relation. So all of you write 5 times this equation, the copy. Magnification is equal to a dash b dash upon ab equal to minus b by u. A dash b dash can be recognized as h2, ab can be recognized as h1. So next point regarding this, again some more points regarding the magnification. Magnification can be positive or can be negative. What does it signify? Okay, I will explain that point. So next is, if magnification is positive, as a note, you can recognize that. What does it represent? M positive. If you are getting M positive after calculation, then M positive means it is virtual image. Virtual image. M positive means it is virtual image. It's a very important point. M negative means it's a real image. Virtual images are, you have to remember, virtual images are always erect. Real images are inverted. The magnification positive means that it is a virtual image. Magnification negative means it is real image. Real images are always inverted in the case of mirror. So take care of this point. And the value of magnification can be equal to 1 in magnitude, can be greater than 1, can be less than 1. We will recognize some of the points, NCERT questions. We will see numerical number 1. What does m equal to plus 1 signify? Okay, this is a board question. What does m equal to plus 1 signify? What is saying this? This is a board question. What does m equal to plus 1 signify? So we can give the answer in two parts here. What, and you have to recognize in which case it is possible. If it is possible, tell me the condition. Okay, in which case, which kind of mirror is possible? M equal plus 1. So first point, you can say that point number 1, you can say you are seeing here plus 1. So plus signifies that it is a virtual image. Okay. Plus means it's a virtual image. Virtual image is always erect, already explained here. And second point, you can see that 1. When you will get 1? Because you have to remember the ratio. M equal to A dash B dash upon AB. You will get 1 only when the size are equal. Both are equivalent. Only when A dash B dash is equal to AB, then only you will get 1. The 1 means that A dash B dash is equal to AB. That means size of the image. Size of the image is equal to size of the object. Size of the image is equal to size of the object. So you have to just recollect from your memory in what case this is possible. That means the image should be virtual and the size of the image should be same as the size of the object. When it will be possible and which type of mirror. So this is possible only in the case of plane mirror. This is possible only in the case of plane mirror. Why it is? Plane mirror, you recognize the image. Plane mirror forms always virtual image, correct image, and size of the image is same as that of the size of the object. So plus sign stands for its virtual image. So you have to just recollect, what all condition you will get virtual image. Plane mirror forms always virtual image. Concave mirror forms virtual image only when the object is between P and F, that is enlarged. And convex mirror forms always virtual image which are diminished. So whenever you hear virtual image, you should get in mind what are the conditions we get virtual image. 3 cases. Plane mirror always virtual image, same size. Concave mirror produces always that means virtual image only when the object is between P and F, that is always what? magnified virtual image is formed. Convex mirror forms always virtual image which is diminished in nature. So this is the way you ought to recognize. So this is numerical number 1. It was a board question. Now I am going to write second point, numerical number 2. What does m equal to -1 signify? And explain the type of mirror and the condition for this. M equal to -1 signify. So m equal to -1. So when you hear -1, so minus sign shows that it is a real image. So it is inverted image. And second point, we are getting 1, which show that again a dash b dash should be same. Then only you will get the 1. So you have to remember the equation for that. M equal to a dash b dash upon a b. You are getting 1 only when they are equal. So that means size of the image is again same as the size of the object. So recollect from the memory, you have to recognize a condition where you are getting a real image and the size is same as that of the object. So then you can recognize that this is possible only in the case of concave mirror. This is possible in the case of concave mirror only at one condition, only when the object is at C. When the object is at C, the image is also formed at C, but the size of the image is real, inverted and of same size. So in this way, you will recognize plus sign stands for magnification. Positive means it is virtual image. If it is negative, it stands for it is a real image, which are always inverted, and the value you can easily recognize. Suppose you are getting m equal to +2. When I am writing numerical number 3, just think about that. Numerical number 3, I am writing m equal to say +3, +2, +1. Is it possible? Is it possible? If it is, in which case, which type of mirror? You have to think. Positive means virtual image. Second one, the +3, m is given by a dash b dash upon ab. So you are getting the ratio as 3. So it's greater than 1. So here m is greater than 1. So what you can say that it is magnified image, enlarged image. So then recognize, you should find a case where virtual enlarged image condition. This is possible only in the case of concave mirror. This is possible in the case of concave mirror when the object is between P and F. Then you will get virtual enlarged image. M plus 3 is possible. So you should know exactly what the size, location of the image. So then only you can do this kind of numerical. It appears in the board paper for 1 mark question. So if I am asking a next one as a numerical number 4, is it possible to get m less than +1 in the case of concave mirror? Less than +1. Less than plus. Is it possible in the case of concave mirror? No. Concave mirror can produce virtual image. That is when the object is between P and F, but it will be always enlarged. So this cannot be possible for concave mirror. But this is possible for what? Which mirror can you recognize? This is possible for only convex. Because it forms always virtual image and diminished image. Virtual and diminished image. So this is about the magnification. So this equation m equal to a dash b dash upon ab equal to h2 by h1 equal to minus v by u. We use this equation the numerical, on the we will see the numerical. So next important point regarding the mirror, what is the sign convention? Only with the sign convention we can find out the location of the image, etc., with the help of mirror formula. So what are the sign conventions that we adopt? The sign convention that we adopted, that is, we call it as Cartesian coordinate system sign convention. Cartesian sign convention. XYZ system. Cartesian coordinate system means XYZ system, that is already known to you. XY system. So what about the sign convention? Cartesian coordinate sign convention for spherical mirrors. That is the next point. Sign convention. For spherical mirrors. For sign convention, this is called it as Cartesian sign convention. Cartesian coordinates XY sets XY system, we take two-dimensional XY, x-axis and y-axis. O is the origin. Toward right side the values are positive, and x dash axis the values are negative, and y-axis upward measurement values are positive, and downward measurement y dash axis negative. So for the sign convention, first we are to keep the mirror so that the pole of the mirror will be at the origin of the coordinate system. So this is your mirror. Suppose I am taking concave mirror. You have to place the mirror in such a way that the pole is at the origin. That is the first point. The pole of the mirror is at the origin. Pole will be at the origin. Once you take the origin coordinate is 0, 0. All the measurements are to be taken from the pole. That is the second point. First point number 1, pole should be at the origin. Second, all measurements are from pole. Taken are from the pole you have to measure. And point number 3, the object should be always on left side. Even if you are left-hander, the diagram should be in the same way. Object per or sign convention, the object should be on left side, always. We have to place object always on left side. Okay. Object should be always on left side, and therefore the light ray should come from left to right. This is the light ray from the object that should go from left to right. So these are the some particular points. So other points I'll explain this again in the next class complete. So we have to continue with the sign convention for spherical mirrors. Next class also will continue along with the mirror formula and with the numericals. So complete the diagrams for convex mirror in the copy, all of you. Okay. Thank you. Other points will continue in the next class.